Hello. Today I'm not doing a vlog. I'm actually going to make a video that kind of talks about a concept in Calc 2 or Calc 3. Probably we're run into this. We have this integral in calculus. Like once you get to this part in calculus, we're going to go over like special integration methods in Calc 2 and Calc 3. And I had a student last night who's asking me a question about this type of problem. So if you're familiar with Calc 2, Calc 3, integration by parts. Integration by parts looks like it's really messy. This is like the main concept here. So when you do it, it's the integral of u dv equals uv minus integral of v du, and you want to choose your u such that every time that you take a derivative of it, you're going to eventually get it closer and closer to 0. So I don't know what this rule really means, but it's like if you're going to have to keep on doing this over and over again, you pick your v and then you integrate that v to get, you integrate your dv, and then you integrate that to get v. Okay, so like if I was to do this, I would say my dv is equal to cos 7x dx, not v. Jeez. Okay. Okay. You want this to be x. And now if I integrate both sides of this, I get v equals, let's do the integral of cos 7x. That's going to be equal to sine over 7. I'm not going to do the u substitution on this. Like if you're at this point in calculus, there's plenty of videos out there that actually cover that content, but there's not a lot of videos that cover what I'm about to show you, which is called the table method. So you get this, sine 7x. And then if we set x squared to u, okay, x squared equals u. If we take the derivative of that, we're going to get 2x dx equals du. Okay, I want to stop here and say you could keep on doing this method over and over again, or you could just use the table method and we could simply keep on taking the derivative of x over and over again until it gets to 0. That's what we're going to end up with. We're going to end up with this chain of alternating signs of derivatives and integrals. So maybe I'll make a video of doing all this stuff by hand, but I only have so much room on this whiteboard, so if I do this, the table method would start out with your u, x squared, and our dv, cos 7x. And rather than going through all this tedious manipulation of saying the integral of dv equals integral of cos 7x dx, and v equals sine 7x over 7, and x squared equals u, 2x dx equals du, and doing that over and over again 3 times. Right? It's the same thing. Doing the same thing over and over again 3 times. So why don't we just take our u, take our dv, and then go through the derivatives? Right? This is all the information that we need to do the question. So we end up with 2x dx for the first derivative, 2, and then finally 0. And then if we integrate, I realize it says cos 7. If I integrate cos 7 over and over again, I'm going to get sine of 7 sine 7x over 7 for the first integral. Got it integrated again. So the integral of sine is negative cos. You know how I know that? If I take the derivative of negative cos, I get sine. That's why. Think about it. An integral is an antiderivative. That's such an important concept, and it'll help you get any integral that you are trying to work with. If you just think of it as an antiderivative, that's how you can calculate that. Okay, so let's do the integral of sine 7x. So we're going to get negative cos, because I got that 7 in the parentheses. I'm going to end up with a 7 squared in the bottom. And now if I integrate this again, I gotta remember to bring down this negative sign. That's already gonna be there. Now if I integrate that cos 7x, I'm just gonna get sine again. Let's get sine of 7x over 7 cubed. You see how this pattern just keeps on going? These trig integrals are just gonna repeat themselves over and over again. But when you put that I'm trying to think of the name of this function. I don't know. A degree of x tied to it. Eventually that derivative is going to go to 0. If we take the derivative of a polynomial over and over again, eventually it gets to 0. So that's the key there. Okay. Now the trick to the table method is, since it's going to be the integral of u dv equals uv minus the integral of v du, this thing right here, we're going to have an alternating sign. So for the first one, we're going to have an alternating sign. So if we look up table method integration by parts, you just have to follow this pattern. Starts out with plus, minus, plus, over and over again. Because the first one is our UV pair, then we get our minus V du, and then we get our plus U. So this happens, this pattern goes back and forth. So first we get plus, because that's our UV, and then we get minus our V du, and then we get our UV. Okay, so the whole integral is going to come out to be x squared times sine of 7x over 7 plus 2x cos 7x over 7 squared minus 2 sine, oh that should be cubed, took derivative 3 times, 2 sine seven cubed. Now if I put this thing into online integral calculator, this is a great way to check your work. I used to use Wolfram Alpha back in the day, but I don't know, one of my students showed me this and it's pretty cool. Cos 7x tells you what you're going to be integrating. Let's see. So you see we got the same exact thing. X squared sine 7x. That's 7 cubed, that's 7 squared. But it's the same exact answer. And look at all the steps that you have to do for this. Every single time you got to do the U substitution. So all this is just following the same U substitution over and over again. but you got to make sure that you're doing your integration correctly. You got to watch out for the signs. So the table method removes that complexity. It's very simple. But you can do it when you have like an x squared or an x cubed or any polynomial to like a degree n. Alright, I hope you find that video helpful, and just keep on watching this stuff, and if I can help someone learn some stuff when it comes to calculus or linear algebra or whatever, just let me know. I'll try and do a math video. Pretty much any math you could think of besides like graduate math, probably.